Well, welcome everybody. I would like to introduce you to welcome you to the 14th annual Okanagan Water Supply Webinar. My name is Nelson Jatel. I'm the Water Stewardship Director here at the Okanagan Basin Water Board. And the theme for today's webinar is One Water, One Community, and Many Needs.
Try to help them out,
As a housekeeping piece, if I could ask everybody to mute your computers, that would be great. We will be recording today's presentation and we'll be sharing it afterwards. I'd like to acknowledge that we are on Silks and Okanagan Nation traditional territory, and it's a pleasure to be here today. So in terms of the presentation team and what we're going to be going through for over the next hour together, I'm going to provide for a little bit of context and talk a little bit about some trends that are taking place here in the Okanagan. We're going to have a report from Natasha Cowie on flow and storage from the BC River Forecast Center, looking at surface water supply, snowpack, and some of the reservoir data. Melissa Wade from the province is going to be talking about groundwater and groundwater supply throughout the Okanagan. Martin Suchy is going to be presenting from International Osyoos Lake Board of Control, and we'll be providing some information about levels and compliance. And we're going to wrap up the formal presentation part today with environmental flow needs and hydrometric risk infrastructure from George Wang from the Okanagan Nation Alliance. If anybody has any questions as we go along, I'd encourage you to type them into the chat. And if we have some time at the end, we'll try to get to as many of them as we can. And for those questions that we don't get to, we'll write them up and sort of circulate them after the fact. Wonderful. Okay. So, as always, this presentation is intended to provide for several layers of information to be able to support decision-making in the Okanagan and water management. So over the next little while, we'll be thinking and talking about flow and snowpack storage in the Okanagan, and also Okanagan Lake and Okanagan River, and get a sense of where things currently are at. We'll have an opportunity to also look at the groundwater layers and really understand that there is a connectivity and there's just one water in the region. And oftentimes groundwater, although it is out of sight, is not out of mind for those of us that are thinking and looking to manage water throughout the year. And then we'll also have an opportunity to look at some precipitation trends, both climate and temperature information as well. So this webinar is a decision support, not an academic presentation. The audience is intended to the audience is making operational and policy decisions in the next 60 days for many cases, and there'll be these three pillars that I just mentioned. The Okanagan Basin is roughly 200 kilometers long. It has about 2/3 the size of Vancouver Island and has about 380,000 people in it today. So one of the context pieces that I like to start off with is this graphic here, which is a graphic of total weekly extraction from surface water in the Okanagan. So you can imagine that this is a good representation of demand for the Okanagan. We are in week 20 here, and we're just about to ramp up for the amount of use. So this gives us a sense of both agriculture and residential applications and use, and gives us a sense of sort of during the hot, dry months of July, August, and into September, the demand for the Okanagan region is the greatest. This next graph provides for some context about the variability. So each one of these red bars is a year of water input into the Okanagan. And so this provides for a 100-year inflow record. The dashed line is the 1981 to 2010 normal. This is a recent decade trending below long-term average. In 2024 to 2025, the water has been well below normal, and we're just going through a fourth year of sort of drought conditions. What else to say about this? I think one of the key pieces to recognize is that in the Okanagan, historically, we have had long multi-year droughts. The 1929 to 31 is one of the most significant on record, and it just demonstrates that this region historically has experienced droughts. Today's webinar is largely about supporting information sharing and the idea that if we have better information, it allows us to make better decisions on Okanagan water. This presentation is provided and presented from the Okanagan Basin Water Board, and we've been working on water and water management issues since 1970. We have 56 years of basin scale water governance, and there's 3 lines of work: water management support, community collaboration, and a number of services, including milfoil control in the Okanagan. One of the things that makes this webinar sort of important at this time of the year is this idea that we are connected. And so we provide this regional approach to practice water management issues. And even though there's variation between drainages, and we acknowledge that it's important for us to be able to manage each water source on its own sort of strategies and development at a sub-basin level. So for example, Kelowna will have a very different water management strategy from Vernon, which will be very different from Kelowna. But we also recognize that we're connected and we need to coordinate these strategies. So each sub-basin has its own hydrology, demand profile, and infrastructure, but the basin is hydrologically connected with Okanagan Lake as the central reservoir. So uncoordinated decisions cascade. Upstream storage drawdown affects downstream supply, and the Osyoos International Lake compliance down south. So very quickly, I'm going to talk a little bit about some water trends and share a few graphics from one of my colleagues, Sandra Shear, about where we're at for some of the things that are going on with water in the Okanagan. This is a representation of the hydrograph. So this shows the amount of water that comes in both as precipitation from snow and rain. The yellow graph is what you would expect from any snow-dominated hydrograph in the province. And what this graph shows is that with climate change, what we're seeing is a shift to the left. So this is our regular hydrograph, but we're seeing that the hydrograph is melting earlier in many cases, and it's also melting faster. When we think about demand for the water supply equation, the Okanagan is one of the fastest growing population centers in the country, largely because of the climate and the beautiful scenery. And the hydrology of the Okanagan region is one of those quality of life characteristics that continues to have people come to this beautiful place. This graphic identifies sort of the 2017 record high flood year, which you see here. It also identifies the 2018 and 2021 and shows how high but typical we have sometimes for this variable and sort of high levels of water. And then in 2022, we start having this lowering trend for precipitation. 2023, we've got a record low. And here we are in 2026 with another significantly low and potentially drought year. Although not necessarily directly water related, this is a trend that's worth noting. This counts both area burned and fire counts. And the water implications are that post-fire runoff carries sediment, nutrients, and change timing of how the water runs off of the landscape. 2017, 2021, and 2023 had events that affected several Okanagan source watersheds, and we anticipate this wildfire trend to potentially continue. In a related sort of trend, and although this comes from Ontario, this is a graphic where we're looking at the number of reported cyanobacteria blooms. Cyanobacteria is a type of organism, algae, single-celled that can produce cyanotoxins, which have the potential for drinking water threats. So using Ontario data, because of their long record, here in the Okanagan, we witness some of the same drivers, and they operate here as well. Warmer water plus nutrient equals more frequent, longer blooms, and this has implications for drinking water, not so much from a supply side, but from a water quality side. And this is one of the trends that we're watching closely. I'd be remiss to look at trends to also not mention the idea that we're preventing and looking to prevent invasive mussels in the Okanagan, zebra, quagga, and now golden mussels. And there is a massive value and economic benefit every year that we don't have economic or zebra or quagga mussels in the region. And so the idea of preventing these mussels from coming into the Okanagan continues to be a significant push for the Okanagan. So the cost of prevention versus projected cost of response of these mussels shows a significant gap. And at the water scale, this is another one of those threats to our water and water supply. I'm now going to switch to some graphics that were designed and put together by my colleague Sandra Shear. This first one here speaks to temperature. So you've got temperature and differences from normal. The Okanagan data is from local weather stations and is more variable year to year than global average, which includes more data points and is therefore smoother. The reference period is 1951 to 1980 for this graphic. And we see here that Kelowna has an increase of 1.17 degrees on average, Vernon 2.9 degrees, and Penticton 2.4. And so the take home here is that Okanagan is warming faster than the global mean. This is the same data as the previous slide, but it's smoothed to show a basin composite, and it identifies a 2.26 Celsius increase versus a 1.17 degree Celsius global warming trend. Once again, showing that the Okanagan has seen some significant warming in the near past. This graphic here compares 1915 to 2000 baseline distributions against a 1991 to 2021. And this shows this whole curve is shifted right, and the right tail is fatter, more extreme heat days. And this is what drives the freshet and demand changes on the next few slides. So this identifies that the last 30 years had consistently warmer weather in June, and then we've also seen more extreme heat events occurring in the last 30 years. Looking at trends, this is looking at Okanagan Lake, and the take home here is that the Okanagan Lake is consistently filling 1 to 2 weeks earlier than normal, and this is a trend that we are seeing again this year. This graphic here looks at trends in terms of precipitation, and really the take home here is that we're in a dry period. We have been for several years, and this year's report showcases sort of this context of where we're coming from. As I sort of wrap up my trend piece, I just wanted to show you a couple of graphics that I just pulled off of the provincial website today. These graphics here look at discharge, the amount of water flowing through some of our system. This first graphic here is of Verdon Creek at the outlet near Kalamalka Lake, and I just want to point out that we are in sort of one of the driest positions that we have at Vernon Creek at outlet. When we start traveling south, when we get to Winfield, this is Clark Creek, which is up on the east side of the basin, and Clark Creek has some of the lowest recorded water flows since record. Continuing now to the central Okanagan for Belgo Creek, same kind of trend. We would expect to sort of be in this green area, and everything is trending low. And then finally, in terms of trending, this is Penticton at Okanagan River in Penticton here in the south, and again, very, very low levels. And my final graphic here is this one that Sandra's put together, and it talks about weekly accumulated precipitation. And we would expect to sort of be somewhere here on a sort of a trend line. And again, this May, we are in one of the lowest precipitation, accumulated precipitation years ever seen on record. I'd be remiss not to do a shout out to one of the key things that we need to be thinking about as we think about water and water management in the Okanagan. That's aging infrastructure. And the Okanagan Lake regulation system is sort of a piece of infrastructure that we need to keep top of mind. All right. Well, I hope that provides for some context. And now I'm going to ask Natasha Cowie from the BC River Forecast Center to provide her report for this morning's webinar. Natasha.
Wonderful, thank you. I'll get my screen share going on.
Yep, looks good.
Okay,
yeah.
Awesome, thank you. Sorry, I only have one screen set up right here, so I couldn't see the chat. All right. Wonderful. Well, good morning, everyone. It's really a pleasure to be speaking to you today, and I really appreciate the invitation to present. My name is Natasha Cowie. I am a hydrologist with the River Forecast Center. I'm speaking to you from the traditional territory of the Lheidli First Nation. So I live up in Prince George. I have visited the Okanagan region many times, really love it there, and I have a couple of pictures that I took in the presentation here from my mountain biking trips to the region. So really just super happy to speak to you today. Unfortunately, I'll be talking a lot about how dry things are, and I really appreciate Dr. Nelson setting up the context for what I'll be discussing today. Also appreciate that inclusion of the precipitation and the hydrograph context too. I'll start by talking about snowpack, and I have the finalized numbers that I just threw in this morning. So our May 1st snow survey and water supply bulletin was just issued a couple of hours ago, and that's up on the River Forecast Center's website now. So I'm going to give just a quick retrospective of how snowpack in the region has evolved. And so this is just showing the southern interior. The Okanagan Basin is in the center here. So as of January 1st, really looking very healthy at about 90% of normal. And these numbers are expressing percent of normal for snow water equivalent, or SWE is the acronym. And snow water equivalent is usually expressed in millimeters, and it refers to the depth of liquid water contained in the snowpack. It is usually a more useful metric from a hydrological perspective than snow depth, because we're really looking at how much water is there. So just for context, that's what I'm talking about here is the snow water equivalent. Started out pretty good in January, really quickly deteriorated as quickly as February, down to 67% of normal, did not improve for March at 62% of normal, and just kept getting worse in April, down to 58% of normal, bringing us to May 1st, and unfortunately we're sitting at 31% of normal for May 1st. And we would usually present some different graphics expressing snowpack metrics, maybe a box plot. There's so little snow in the region now at the monitoring stations that there just really wasn't too much to show in terms of graphs, but I managed to pull a few things here. One thing that I thought might be a useful illustration is the normalized difference snow index. And so a big, long, fancy word, with a convenient acronym, NDSI. This is a satellite-based data product that just expresses coarse scale approximate coverage of snow within a watershed. So it doesn't tell you anything about how much the depth or the snow water equivalent, but it tells you the coverage within a watershed. So this is a few days ago as of May 2, and it's showing across the whole region, all around the Okanagan, very, very low snow coverage. For a few examples of these satellite images, these are from Sentinel-2. They're all actually publicly available from this site, Copernicus browser, great resource. Coldstream Creek watershed, no snow. Whiteman Creek watershed, and this was as of April 26. We had some clouds, I think, or something more recently. A little bit of snow hanging on, that's probably gone now. Inconneep Creek, basically no snow as of May 3. And then I'm going to just give an example here of the Mission Creek watershed on the next slide. So tiny bit of snow hanging on at the higher elevations there. So whoops, I apologize. I got my animations out of order here because I wanted to get you the most up-to-date hydrograph. So a little bit of a spoiler there for where I'm going with this. Just pretend I didn't show that yet. So within the Mission Creek watershed, just to give you a visual for how this looks year to year, when we have high snowpack versus low snowpack years and the impacts on the hydrograph. This was May 5, 2018. There's a little bit of cloud cover on that day, but you can tell there's a lot of snow in the watershed at that time. And 2018, actually just a few days after this image was taken, is when the record high to date for that gauge was recorded at about 95 cubic meters per second for the daily average. So these graphs are, the hydrographs, I've simplified them a little bit. They're just showing in these dashed lines the maximum daily flows in the blue dashed line and the minimum daily flows historically in the red dashed line. And then this gray line is the long-term average flows. So taking us up to about the same time last year, May 6 of last year. So decent amount of snowpack hanging on in the upper reaches of the watershed, not nearly as much as 2018, but reasonable amount. And last year we had pretty average peak for Mission Creek at about 37 cubic meters per second, lining up well in magnitude and timing with the historical long-term mean. So bringing us to early May of this year. So this is a few days old. So expect there'll be even less snow up there now. As of May 3, still had a bit of snow hanging on, but less, even just at a visual glance, less than last year at the same time. And I just pulled in, that's why my animations were wrong. I wanted to get you the up-to-date one. This is as of up through yesterday, the hydrograph for Mission Creek. And it did reach this one little initial peak. I don't know that that's necessarily going to be the absolute freshet peak. It's tracking about average for the time of year right now, but probably on track for overall a lower peak compared to historical by quite a bit. So a little bit more talk about the snowpack here, just to give you some more examples of how things are looking. And I apologize, I feel like I'm just telling you in so many different ways that there's very little snow. There really is very little snow, but hoping that these different visuals kind of give you a little bit of an impression of how this actually is shaping up on the ground around the basin. So a few examples. These are going to be graphs from automated snow weather stations with the longer term periods of record around the basin. So the different colors in the background here are representing historical percentile ranges. So green would be kind of the normal range. And then this year's is that black line. Last year's is the green line, a little hard to see. So Grayback Reservoir, we've got 9 years of historical data there. And it went to 0 millimeters snow water equivalent on April 20, really early, earliest on record. In 2025, it was out on May 1st. Brenda Mine, so much longer period of record here, 30 years, and by quite a bit, this was the earliest it was out of snow. It went to 0 on April 10 compared to late April last year. A couple of higher elevation locations. Mission Creek, really nice long historical period of record here at 55 years, close to 1,800 meters above sea level. It's around the 11th percentile right now. I just checked it again. This graph is a couple days old. 2025, it was not out of snow until June 20, but it's hanging on all right for now, but very low. And then Silver Star, 9 years of record, over 1,800 meters above sea level, and it is at the 0 percentile. There's still snow, extremely low though. That typically goes out mid-June. So now moving into an overview of the monthly inflow forecasts for Kalamalka Lake and Okanagan Lake will be on the next slide. So I know there's a lot going on these slides. I've pulled some satellite images, and these are mosaic images from last summer, just to, again, to give that visual reference, because I'm throwing a bunch of graphs in here. So yeah, a lot going on here, but the blue bars are the observed inflows. The yellow box and whisker plots here are showing the results of the ensemble model. So this is kind of just essentially putting in a range of different scenarios and saying, okay, what's the possible minimum and maximum? What is the likely range? So that 25th to 75th percentile band, that's kind of considered the most likely range of scenarios from here. Going forward through the summer and into early fall, what are we expecting to most likely see? And then these green diamonds are the 1970 to 2019 normals for each month. So this is really showing us how we're lining up in terms of observed to date since October for the water year, and then going forward, how are we lining up against the longer term normal? And it is, unfortunately, we were tracking all right compared to normal earlier in the winter. That's now just taking a pretty steep dive. And as you can see in May, and for May, this is just observed to date in May, that blue bar. So that can be expected to get a little higher, but we are just massively far below the historical normal, and not a particularly sunny outlook for inflows over the next few months. Looking at Okanagan Lake, kind of a similar story as well. We were tracking not too far off the normals until now. And so these forecasts going forward, now that we're pretty much out of snow, are getting low very quickly for inflows. And then just another look at this, and again, kind of a lot going on in this plot, but this is for Kalamalka Lake over on the left-hand side, Okanagan Lake on the right-hand side, and I'm going to be showing numbers in red indicating the percent of normal for these different time periods. So we've got, this a little seems a little out of order, but this is the May to July is the one on the far left, and then shorter term May to June, and then longer term May to September on the right. Looking extremely low compared to normal again. So minus 1%, so actual negative total net flow for Kalamalka in May to July period. A little better in May to June, but this is only 9% of the long-term normal, and looking very dry, very, very low for May to September. Relatively a little bit more positive for Okanagan Lake, but still pretty bad. 17% of normal May to July, 19% May to June, and then 11% of normal for that longer term May to September period. One more look at this. This is the next 10 days, or this model was run on the 6th. So we're already a day in. This is a 10-day inflows forecast for Okanagan Lake. Tracking, again, well below normal. Well out of range as a result of the very dry conditions and the very low snowpack. So I'm going to show just very quickly here. This is some information that I got this morning from colleagues in the flood safety section. So this is not RFC derived information. So if you have any questions about this, put them in the chat. I may need to redirect you for some of these questions, but I will do what I can to get you in touch with the right person. So with regards to Okanagan Lake level management, for outflows, the outflows at Penticton are currently at 3 cubic meters per second. The flows at Oliver are fluctuating between about 8 and 10 cubic meters per second. So this is above the minimum required flow of 6.5 cubic meters per second for May. The levels, the current level is 341.8 meters, and this is about 0.5, 0.6 meters below full supply level. If the current minimum outflows are maintained, the peak level is expected to reach about 342.28 meters. So that's 0.2 meters, 20 centimeters below FSL. So this is really comparable to the conditions that were observed in 2024 so far. The operating strategy going forward is to maximize the lake storage while monitoring the tributary inflows downstream of the lake to meet the required flow targets in Oliver. So just in summary, and feel free to reach out to us with questions. Here's our email address. We're anticipating well below normal runoff for the rest of spring and into the summer. Essentially, there is no snowpack-driven seasonal flood hazard remaining. I have not talked at all about flood hazard. Hazard from rainfall always remains a possibility, particularly localized high-intensity events, but snow is pretty much done in the region. We are facing, unfortunately, high drought vulnerability going forward due to the extremely low snowpack and the rapid melt. Thanks for your time, everyone, and please feel free to reach out with any questions.
Natasha, thank you so much. That was fantastic. Really appreciate it. Next, I would like to invite Melissa Wade from the province to be able to provide for an update on our groundwater and our groundwater outlook for 2026.
Okay, thank you. Do you want me to share?
If you wouldn't mind, that would be great.
Yeah.
I've Yeah, enable that.
Okay. Okay. Am I stopped? Okay. I'll start talking. Yeah, thank you for having me. So I'm Melissa Wade. I'm a regional hydrogeologist with the province of BC. I'm going to give the groundwater conditions update for the Okanagan region. I'm with the Ministry of Waterland and Resource Stewardship. I'm a member of the South Area Water Authorization Science and Monitoring Team. We used to be called the Groundwater Science Team, but we had a reorg and rebrand, a little bit of a rebrand. I live and work in Kamloops on the traditional and unceded territory of the Kamloops to Secwepemc. So
You're good to go, Melissa.
Yeah, I can see it. Okay, thank you. Now I'm just wondering if I want to point at stuff. Oh, I can annotate. That's okay. Next slide, please. Okay, so as probably most of you know, the province maintains a network of groundwater observation wells throughout the Okanagan and the province to monitor groundwater levels in developed aquifers. I'm going to take you through a quick tour of some of these, starting in the North Okanagan and moving south. Oh, just wondering if I could. Ooh. Oh, see if I could point my mouse at things. That's okay, I'll just describe. So first I'll just orient you to the slides. On the left, it shows the map of where the observation well is. So we're going to start at observation well 180 in Spalumcheen near Armstrong. The graph on the top right is the current groundwater level shown with the color banded percentiles behind it. The gray line is the median for this well, and the dashed black line is last year's water level. Water levels are shown in meters below ground surface, which are increasing as you go down. So as the line goes up, that's the water level moving up. And as it goes down, that's decrease in water level. And we're showing the water year here, which is October to October. I pulled these charts just over the last couple of days, so they're current as of May 6th or 7th. And at the bottom, you'll see the historical hydrograph, which just shows the longer period of record. All right, so now let's talk about the water levels here at observation well 180. The 2023 and 24 water levels were in the normal to above normal range. Last year, it started near the median and then kind of dropped below. This year, it's currently in the below normal range, and it's about 30 centimeters below last year's level. If you look down at the historical chart, you'll see at this location, we've had a bit of a declining trend since about 2020. It's overall declined about 2 meters in the last 6 years. Next slide, please. So next, we're moving down the valley to observation well 442, Ellison observation well near the airport. This is completed in aquifer 464, which is called the Greater Kelowna Aquifer. It's a confined aquifer, so it's less directly influenced by surface water levels. But similar to the Spalumcheen well near Armstrong, the water levels started out at a similar level as last year, and now they're kind of 30 centimeters below last year's level. And next slide, please. Now we're at the Rutland observation well. This one's completed in the same aquifer, just further south. So it's also in the confined Greater Kelowna Aquifer. It's still in the green normal range and showing a similar trend as last year's level. And it's currently about 40 centimeters lower than last year. And again, if you look at the historical groundwater levels down below, this location's also had a bit of a declining trend of about 2 meters since 2020. Next slide, please. This one is Upper Trout Creek observation well 412. This one's completed in a bedrock aquifer. It's a bit higher up in the watershed above Summerland. It's currently 1 meter above last year's level in the yellow, but still in the yellow below normal range. And then if you're wondering, I just thought I would add, if you're wondering why this one looks so flashy than some of the other observation wells, this is because it's completed in bedrock, and just in general, bedrock aquifers have much lower transmissivity than the unconsolidated sands and gravel aquifers, and they tend to have a bit more flashy, quick response to snow melt and heavy precipitation events. So it looks like we had a couple peaks there early in January. February was a bit of one, and I know that it was quite warm in February, so maybe some snow melt there, and then quite a bit in March, April. Next slide, please. Down further to observation well 403, right near Twin Lakes. This one is in a sand and gravel unconfined aquifer, following seasonal trends, but maybe declining a little bit earlier than last year. It's currently in the below normal category and about 30 centimeters below last year's level. Next slide, please. This was observation well 282 in Willowbrook. If the groundwater levels are showing a flat line above median since February, but they are last year the groundwater levels were above normal, but this year we're just kind of right at median. Next slide. Okay, observation well 407. This one's just north of Oliver in an unconfined sand and gravel aquifer. This one's hydraulically influenced by the Okanagan River. The water levels began the year tracking similar to last year, and similar to last year, start to decline in about April. That start of the decline is about April 16th. Normally at this well, the hydrometric peak, we see there's a delay between the Okanagan River hydrometric peak and the groundwater peak of about 10 days. So I was hoping there would maybe still be a peak in the river that we would see here, but based on Natasha's update of the forecast inflows to Okanagan Lake, it's probably not likely. So we're sitting right now at historical lows for this well. Next slide, please. Observation well 405 in Oliver. This one is a semi-confined sand and gravel aquifer. Groundwater levels are following similar trend as last year and currently nearing last year's level in the below normal range. And I just was going to note that this well doesn't have a huge range of variability throughout the year. There's only about 2 meters of variation annually. And the last 5 years of data have kind of been within 30 centimeters for this time of year. So this one's pretty consistent. And last slide, next slide. This is the last observation well here. For the south, this is observation well 402 on Anarchist Mountain. This one is also a bedrock well higher up in the watershed just above Osyoos. And it appears to have already peaked for the season, and it's about 3 weeks earlier than last year and currently 1.7 meters below the level for last year. And this observation well, again, because bedrock, heavily influenced by snowmelt and precipitation, which is seen in that increase in January, a little bit in January, and then in March. Next slide. So just overall summary, North Okanagan in general, they're mostly at the bottom of the green normal range or just into the below normal range. A lot of them are sitting about 30 to 40 centimeters below the same the levels at the same time last year. Central Okanagan is also mainly in that yellow below normal range. And the South Okanagan's a little bit more variable. The one confined aquifer well at Willowbrook was just above median, but the two unconfined aquifers in Oliver 405 and 407 were showing below normal and historical low respectively. And the bedrock well at Anarchist Mountain was also below historical for this time of year. And just note that the groundwater levels can vary between localities, and you can consult local real-time stations for current conditions. Next slide. So this is the link where if you would like, you can go and access all the provincial groundwater levels that are available. That's the link there. There's also the QR code, but as you know, a lot of the government links change through time, so it's very easy just to search in Google BC Provincial Observation Well Network, and it should take you to this online mapper. And also, here's just the regional groundwater staff. If you want to reach out for any more questions, John Pogson, Jeff Corey, and Laura are in Penticton, and David Thompson's in Vernon, and then Lori Lyons, myself, and Stephanie Drake are in Kamloops. And I think that is it for me. Next slide. Yep.
Melissa, thank you very much. That was absolutely fantastic, and really appreciate a sense of what's going on with groundwater in the Okanagan. So thank you very much.
Yeah, thank you.
Next up, I would like to invite Martin Suchy to present on Osyoos Lake and some of the stuff that is currently relevant to the basin as a whole, but through the lens of the Osyoos International Lake group. So, Martin, welcome.
Okay.
Great to see you.
Yeah, thanks, Nelson. I'm just going to pull up my slide deck here. And let me know if you can see that.
Looks great. Thanks, Martin.
Okay, yeah, so my name is Martin Suchy. I'm with Environment Climate Change Canada, part of the National Hydrological Service, and I am also the Canadian Section Secretary to the International Osyoos Lake Board of Control. And just going to present a little bit about the board and what we're doing right now. So a little quick background. So board is appointed and operates under the International Joint Commission. And the board monitors the provisions of the order for the management of Osyoos Lake. We are currently operating under the 2013 supplemental order, and that order is due to be updated prior to 2038. There are currently two rule curves, a normal conditions and a dry drought conditions rule curve. Osyoos Lake levels are generally regulated by Zozel Dam, which was rebuilt in 1987. It's located on the Okanagan River near Oroville. And a couple other notable points here is that the Similkameen River discharge can impact Osyoos Lake outflows, especially at flows above 280 CMS, 10,000 CFS. And in fact, at very high Similkameen River flows and low Okanagan flows, we can get a reversal flow into Osyoos Lake from below the dam. And other things are ice jams can also affect lake outflows. So I wanted just to start with a quick summary of what conditions have been like since the supplemental order was implemented in 2013. With the table here on the left, you can see the kind of orange, red, and yellow colors signify dry year conditions. And so there's been very few normal kind of average years. There was 3 years with Osyoos Lake flooding, and 7 of the last 14 years have been dry or drought-like conditions. Twice, the board had to recommend and grant a condition 10 variance, which allows the operator to operate the lake and the dam at as if drought conditions were met. And twice we've met drought criteria. And as of for 2026, the board just declared drought today, this morning. So I'll get to that shortly. But you can see here on the hydrograph on the bottom right, the dark red line is 2026, and the black line is the normal rule curve, and the dashed red line above is and below is the condition 8 drought criteria rule curve, which allows more flexibility to operate lake levels. I'm going to skip the snowpack stuff because Natasha touched on some of that. But I did want to touch base on what's happening on the Similkameen because, like I said, it does affect Osyoos Lake, and it has an impact on drought declaration. So in terms of what we're looking at for the Similkameen River, it's the total volume of flow forecasted for the period of April 1st to July 31st. You can see this whisker plot in the top left here. And generally, at least for the past month or two, those forecasts have been below the normal, but above that dashed red line, which is the drought criteria equivalent to 1 million acre feet. And as of yesterday, that April to July forecast from the Northwest River Forecast Center is just over 1 million acre feet at 1,084,000, but it's decreasing every day, and that's a forecast that comes out every day. On the bottom plot there, you can see a hydrograph of the Similkameen River with the light blue being 2026 and the thinner dark blue line being 2025 for comparison. Current flows in the Similkameen are above 10,000 CFS, 306 CMS. Oops. Over on the Okanagan, again, we've seen some of this, but I just wanted to touch on a couple things that are important to the board here. The top left plot is a whisker plot of Okanagan Lake net inflow. This is an ensemble stream prediction model, Raven model run by the BC River Forecast Center. This is something that we have adopted new this year. So the River Forecast Center, starting in January, has been producing these forecasts for us every 2 weeks, and then since the beginning of April on a weekly basis. And this is what we're relying on for long-term or the seasonal forecast and what the Okanagan Lake inflow is. And this is, again, critical because this is one of the criteria for drought declaration. The plot on the right, again, just showing the monthly inflow volume ensemble forecasts. And again, as Natasha indicated, it was near normal, normal being the green diamonds, but May has really fallen off, and we're well below normal for the month of May. The bottom left plot there, that's kind of our cumulative April to July net inflow. And so, we're partway into May. It's below the mean or the median and well below that dash red line, which is our criteria. We do not expect to meet that, but I will get to that shortly. And then, of course, the bottom right plot is Okanagan Lake at Kelowna. This is a water survey gauge. Again, this is critical because there's that dash red line, which is the drought criteria for Okanagan Lake. If that does not meet that again is one of the criteria for Osyoos Lake meeting drought declaration. And then over with some hydrographs, again, we've got Penticton in the top left. That's Okanagan River, Penticton, Okanagan River near Oliver on the top right, and then Okanagan River at Orville. And just the key things that I wanted to point out here is just the differences in flows. So very little flow coming out of Penticton Dam, 3.2 CMS. The flows at Oliver are in around 9, and so that's unregulated tributary inflow on the main stem. So there's a positive delta there. And then, of course, the outflows from Osyoos Lake at Zolzol Dam are just below 6 CMS. And so they are storing water in Osyoos Lake. So to those drought criteria I mentioned earlier, so the Similkameen, just over 1 million acre feet right now, and we have called that as being effectively met because that keeps dropping on a daily basis. For the Okanagan Lake net inflow for the period of April to July, we are currently 118,000 acre feet. Last week was 187, and the last week dropped below the criteria for the first time. And then that Okanagan Lake level, we're possibly going to meet that, but it's actually not that important because only one of the two Okanagan Lake criteria have to be met along with the Similkameen. So with that, the board has made a decision to declare the Condition 8 conditions being met and has now has notified the Washington Department of Ecology that they can operate Osyoos Lake and Zozo Dam such that they can store an additional half a foot of water. And so that's that dashed red line on the high side. And of course, that also means that later in the season, should water be scarce, they can operate lower than under normal conditions. So a couple things on this plot, the hydrograph. So the bright green is 2026. Started off similar to 2025 in the water year. The 2025 is the darker green, thinner line there. But once we got into the winter here, and especially February, March, April, January, February, March, levels dropped to near historic lows. Those are the gray kind of percentiles there. Those are since 1987, so at least since the new dam was constructed. We have a wider range for the period of record for if you go back to the 1920s. But with the current dam, that is basically from late January until late March. That was a new historic low for that time of the year. Levels were kept low because they kept lake level outflows to a minimum to meet kind of minimum ecological flow needs for salmon reds. And once those spawn, they basically shut the outflow out, and then we see this rapid rise in the lake level from about mid-March until right now in early May, when they reach the top of the normal rule curve. That's the thin black line. And of course, like I mentioned, we've declared drought conditions being met, and so there's an extra half a foot of storage will allow for water to be held and available later into the season. That's it. Thanks very much.
Thanks, Martin. As always, really appreciate the update and the perspective for the Okanagan. Next, I would like to invite George Wang to provide for a presentation on hydrometrics and the hydrometric network for the Okanagan. George.
Yeah, of course. Thanks, Nelson. Just give me a second to share my screen.
Looks great, George.
Okay, cool. Yeah. Good morning, everyone. My name is George Wang. I'm the hydrologist with Okanagan Nation Alliance Fisheries and Natural Resource Department. I oversee the largest network of hydrometric stations within our basin and surrounding areas. So today I'm pleased to present a topic fundamental to our water management in this region, adapting hydrometric monitoring for drought, flood, and water supply resilience. So this presentation was co-authored by Nelson Jatel, Water Stewardship Director at OBWB, and myself. So with Okanagan entering the fourth consecutive drought year, this raises an important question. So why does monitoring matter? Simply put, we can't manage what we don't measure. So I'd like to share some information regarding the droughts and floods occurred in this region. So on October 7, 2025, Okanagan still had drought level 4, unprecedented and critical change at that time of year. So to monitoring drought, I think lots of other presenters already share those information. Several factors, indicators are used, like the precipitation, stream flow, lake level, and groundwater level. It is important to note that Water Supply Canada hydrometric stations used to assign these levels are primarily located in headwaters or upstream areas, so they don't fully capture the drought conditions in our valley bottom, where most communities' agriculture water use is concentrated. In September 2025, our field observations confirmed the severity of the drought. So as you can see in these photos, we documented dry reaches at Shuttleworth Creek, Vassal Creek, and McDougall Creek. I know our topic is drought. I just want to bring a little bit of information and news regarding the flood because they're kind of connected. So flood has occurred across spring freshet across our region. So from White Man Creek and Shuttleworth Creek in spring 2023 to Bear Creek in spring 2025, each or like flood events have repeatedly threatened homes, roads, and communities. As you can see these snapshots, so each flood has had real impacts on the ground. Some floods like those White Man Creek and Bear Creek occurred at watersheds recently affected by wildfire. So post-wildfire landscapes increase runoff and debris flow, making flood more severe and less predictable. So all these images highlight not only the severity of these events, but also the frequency and the variability across watersheds. So the lesson is clear: to mitigate climate extremes, whether mitigating flood risk during freshet or optimizing water storage across the basin for drought resilience, we need accurate, timely, and comprehensive hydrometric data to understand risk and support effective water management decisions. So our hydrometric program, sorry, just pop out like a poll. Our hydrometric program supports the BC Drought and Water Scarcity Operation Plan, April 2023. And it is important to emphasize that hydrometric monitoring is not just data collection, it is core infrastructure for risk management, supporting drought, flood, and water supply resilience. So this map shows all the hydrometric stations monitored and operated by ONA, spanning from North Okanagan to South Okanagan and surrounding areas. So this slide shows the hydrometric data for Mission Creek on BC Web Portal. We running the station and the data eventually imported into the BC Web Portal. The data is current with a few hours delay. So for any of you who are interested, you can visit BC Web Portal to search our stations or any creeks of interest and explore the data into more details. Access to real-time environment flow information is critical for fisheries management and supports the aquatic ecosystems. So this Shiny app helps balance the environment flow requirements with competing water demands, including irrigation, municipal supply, and other water uses, other essential water uses. So this slide shows the real-time data for Equistis Creek, and integrated with the environment flow information, allowing real-time comparison. So as you can see, the flow, this black line is the current flow data. So now it sits generally below the 10 percentile. So it's very low as introduced by all the other presenters. So similarly, this is the Power Creek real-time data integrated with the environmental flow information. And as you can see, it dropped below like between generally minimum to 10th percentile, and it is approaching the EFN. The red line is the EFN, and the yellow line is the CEFT. So similarly, this is the real-time data for McDougall Creek integrated with the environmental flow information. It is important to note that following the 2023 McDougall wildfire, the timing of freshet shifted 1 month earlier. So generally from the late April to early May to late March to early April. And you can see that this is the May 7 data. So the real time is already dropped below the EFN. So thank you. Please feel free to reach out to Nelson and myself if you have any questions. Let me know. Thanks.
Thank you very much, George. As always, that was fantastic. Okay, well, with that, we're at 12:03, and I don't see any questions in the question blog, so I think I'm going to just stop there. I'd like to thank all of our presenters today, Natasha, Melissa, Martin, and George. Really appreciate this quick 1 hour look at the Okanagan. And as many of the people have noted throughout the presentation today, the Okanagan is trending dry. With that, I wish you all a great weekend. And if anybody has any questions, by all means, feel free to reach out to myself or any of the presenters. Have a great day, everybody. Thank you.